Great. So as people filter in, maybe we'll start with some introductions. So welcome to the webinar, everybody. My name's James Clough. I'm the VP of Engineering here at Encord, and I'm joined by Swapnil Sahai, who's the co-founder and CEO of SwingVision. And yeah, our topic for today, we're going to be talking about the build versus buy decision for production-ready AI infrastructure. So yeah, some quick intros for me and Swapnil, and then we'll get into things. So yeah, my name's James. I'm the VP of Engineering at Encord. My background is actually in AI research as well, first in academia, and then as the CTO of a company building AI for the legal sector. Now at Encord, leading our engineering team, which is about 20 engineers, building out our AI data platform. Swapnil, I'll ask you to give a bit more detail about SwingVision in a second, but give us a quick introduction to yourself.
Yeah, hey everybody, I'm Swapnil. I come from machine learning background in autonomous driving and computer vision. So that's kind of where I was before I started SwingVision. And then initially it was sort of like a technical co-founder, I guess, with my co-founder and CTO, but now obviously moving more to just CEO duties over time. I've been at SwingVision for 6 years now. And our entire company is about 25 people. So pretty small still.
But you know, growing fast. Nice. Cool. So yeah, what are we going to discuss today? So you know, the goal of the session really is to explore the build versus buy decision for applied AI companies like SwingVision, and ask, when does it make sense to use your own data annotation tooling? When does it make sense to partner with an existing provider? And what are the signals that people should be looking for to know that it's time to ask this question, or when it's time to transition from one kind of solution to another? We'll talk about the technical aspects and the commercial aspects. It's not just the technical decision, it's about sort of speed of product development, but also about time to market, about ROI, and about how you can build the right stack that lets you out-execute your competitors. We'll explore SwingVision's journey in more detail, but hopefully draw out more general conclusions as well. So whether you're listening in and doing AI for retail, for robotics, for healthcare, or really for any application, I think any team that will hit the point where strategic tooling choices defines and determines your ability to scale, there should be something useful to learn from today. Just a quick introduction to Encord before we get into that. So Encord is an AI data platform. We're here to help you manage and curate and annotate your AI data. So throughout the webinar today, we're going to have a few polls to keep things interactive. So we can launch our first poll now, where you can tell us where your team is with production AI. But Encord lets you automate data preparation and build high quality data sets for training AI systems. We're very multimodal, so we support image, we support video use cases like SwingVision's, but we also support audio, text, documents, and now data from physical systems such as robots, autonomous vehicles, and drones as well. And we support that data end to end. So we support indexing and curation, finding the right data for your application from very large amounts of unstructured data that you might have access to, annotation, and also active learning. So at inference time for deployed systems, debugging errors in your models, finding those edge cases. We'll talk about edge cases a lot. Finding those edge cases in production, and continually improving performance by learning from your deployed systems. So on to SwingVision. So Swapnil, tell us the story of the business. What are you building, and who are you building it for?
Yeah, so we really kind of built it for ourselves initially as tennis players, but the idea really was, we saw all of our friends with using Strava for their running and their cycling, or they're using AllTrails for their hiking, and there was no way to really track or like share your game in racket sports in general. So we saw a pretty interesting opportunity there. And then yeah, with my background in autonomous driving, computer vision, felt like we should be able to solve this problem using computer vision and tracking the ball, generating stats for the players, making it really easy for them to understand, improve, and share their game. And one thing that we decided to do very early on from the first stage was do all of our machine learning on device, which obviously has its own sets of constraints that imposes on what kinds of models you can run, and how the software is built. Yeah, ultimately we launched the first version of SwingVision almost 6 years ago, and you basically set up your phone behind the court, like in this video, and all of the machine learning is run on device. And we basically track like the player movements, the ball trajectory, where it's landing, how fast is your serve, how accurate is your forehand. So you can see all those kinds of stats. And we really geared this towards, I'd say, amateur club level tennis players. So adults who are, maybe playing like leagues, matches on the weekend. But over time, it's really evolved. And we have college teams, over 100 college teams using SwingVision now. We have junior athletes, like high school players who are aspiring to go to college, also using SwingVision. And then we've also expanded to additional sports since starting in tennis. So it's definitely been a journey, but I think we've still kind of stayed true to that core idea of, essentially making it a really great way to just track, share, and improve your game.
Nice. Yeah, I think all the best startups are founded by people who are trying to solve a problem for themselves, right? And who you actually feel it yourself. And you say you started with amateur and club, but I saw on your website there's some endorsements from some very non-amateur players, right?
Yeah, definitely. Some of our earliest investors were former professional players. One of them is Andy Roddick, who was US Open champion, which is a tournament that's happening right now in New York. So yeah, we've been really fortunate to have the backing of some really great players and associations from the tennis world.
Nice. Who's your tip for the US Open?
Oh man, I mean, my boy is Alcaraz, so I gotta go with him. I don't like his haircut, but I like his game. So
nice. And thinking about the journey you've been on over the last 6 years, what would you say have been the kind of the key milestones recently? You talked about adding more sports as well, but that evolution from selling to individuals and amateurs to bigger teams. What did that look like for you?
Yeah, I think initially, obviously, it was just very direct to consumer, and we very quickly started to build a relationship with Apple, and they started featuring us a bunch, and keynotes and all this stuff. And so we were very just consumer app focused for the first few years. Once we started to get some semblance of product market fit, our retention curves are actually flattening. We're seeing some reasonable renewal rates for our subscription product. We just organically started to see college athletes using it and college coaches specifically. And so just kind of, started to use SwingVision in a different capacity. And then we decided to build an entire product experience for colleges. They typically have a scenario where they have 6 matches on it at once. And so we had to build lots of new software for them to be able to manage 6 recordings simultaneously and track all of that, and build it for an iPad because they love using larger displays. Because actually the way they do it is they'll play matches, and then on the way back home, in the bus, the kids, the college students will all just watch their match they just played and kind of self-diagnose what they could have done better. And so it's really become an integral part of their workflow there. And then one, I guess, pivotal thing for us was when we introduced the ability to do line calling. So initially we were just focusing on stats, but our AI started to get so accurate at tracking the ball that we could actually tell you whether the ball is in or out. And we were able to do that better than the human eye at a certain point. And so we started to realize oh, actually there's an interesting opportunity here where SwingVision could actually be essentially officiating matches across all levels of the sport. And if you've ever watched tennis on TV, you'll see that it's all automated now, the line calling. There's no linesman. And so there's a company that does that requires 10 cameras, very, very expensive, tens of thousands of dollars. And so we saw a unique opportunity to bring that type of technology to, college, adults, junior, everywhere else where it's not there. And so then that started to really force us to focus on accuracy, and that started to become a company priority, more so than it was before. And so, that's kind of how it started to evolve. And then, from that, we started naturally talking to tournament organizers and national tennis associations that are organizing events all throughout their country. And so it's kind of just increase in scope and scale in terms of, what we want to pursue. And then I guess at the same time, we started to see other sports growing very quickly. So, pickleball, obviously growing very fast. And so we saw an opportunity that, hey, everything that we've done in this vertical, we could do the same thing in pickleball. And then, so I think that was an interesting opportunity for us to expand and just prove to ourselves that we can do this in another sport. And I think that's going to be very important for us going forward because there's lots of other racket sports, maybe even non-racket sports, where we could apply what we've built.
Yeah, no, they're super interesting. Yeah, pickleball, I think is sort of taking a while to make it to London, but it's getting in. So yeah, I think migrating over from the US. So I'll be excited to see that pick up here. Maybe one last question for you here. What I suppose your customer has changed a little bit from that sort of B2C motion, the amateur, to more professional organizations. But what do they see as your key differentiators, maybe compared to what they had before or what else was in the market?
Yeah, that's a good question. So, it's interesting, like looking at the market for consumers, there basically was nothing before. Like they didn't have a way to do this at all. This category didn't exist. For colleges, they actually were using some services that are kind of in between where we are and what the pros use in the Grand Slams. So it was still like dedicated hardware on the court, but very expensive. So maybe only like the really top Division I teams with really big budgets or like in the big conferences would actually be able to afford it. And so, it was, first of all, it's just like the price point is like an order of magnitude less.
Yeah.
And then the scalability too, like being able to then do that on multiple courts, being able to take this on the road when you're playing somewhere else because it's not fixed hardware. That was huge for the college teams. And then we've seen that also with the tournament organizers. So there are multiple software solutions that are trying to provide this electronic line calling technology at the tournament level. But again, ours is the most scalable because it doesn't require hardware to be installed on the court. It's just using a phone. You can pick it up, you can move it. If you have a rain delay, you can move stuff back inside. So I think just the portability of that. And again, it's interesting, like we happen to focus a lot on device machine learning very early. And that was actually essential to be able to provide things like line calling. You can't possibly do that if you're streaming the video and running inference in the cloud. It's just going to have too much latency. So it's kind of interesting. So all of that focus early on actually really paid off as well. And so that's been a big differentiator too, in terms of anybody else who's trying to build a mobile solution. We just have such a big lead there now in terms of on device. And so that also kind of helps differentiate us going forward.
Nice. Yeah, I guess on device adds a few technical challenges, and maybe we can go on to talk about those as we go through as well.
Yeah.
Nice. So yeah, moving on to think about the sort of the build versus buy decision. I think, from my experience in startups at the sort of application layer in AI, I think there's this typical story where you begin, I suppose it's startups, scale ups, and bigger enterprises as well that have newer AI teams. You have a story where you often begin with your own tooling. It's kind of quickly hacked together. The focus at first is on learning and iterating, and so you don't want to commit to lots of spend. And you're perhaps not trying to scale it, but you're just trying to experiment quickly and learn the right sort of setup. And then there's often a transition at some point where development and maintenance costs can get higher. Perhaps it's a distraction away, distracting focus away from your core business. There might be compliance concerns in some cases, or you just feel that higher quality tooling can help you scale or help you go faster. I suppose, yeah, maybe a first question for you is, does that characterization match your experience? And what was that initial internal build looking like for SwingVision?
Yeah, that was exactly the story for us. We did actually interestingly consider some services like very early on, but they were just like way too expensive for the scale of our business at that time. Like we were just starting out and our funding was like pretty limited. So it just like wasn't really a viable option. And also actually at that time, like I think even still today, like a lot of solutions like this weren't doing a good job with like video annotation specifically, which is very important for us. And that's something obviously Encord does really well. So ended up being amazing for us later down the road. But yeah, initially we just basically like forked our own version of like CVAT, which is just an open source annotation tool. And it was basically just coded by our ML engineers who are, obviously not like front end developers, but they just hacked it together and it was good enough. And then it was fine in the beginning. We still continued to use that even until we had like hit product market fit and, got to like the subscribers and the thousands of customers. But yeah, it did start to get to a point where the maintenance part was actually pretty tricky. You mentioned this on the slide, like at one point we were trying to add some new features, especially as we were like expanding to pickleball and stuff. And it started to just become like a pain to add like new ontologies or just change things up because we realized we had forked a CVAT that was like 2 years old. And it was like very difficult now to, come up to the latest version. And our ML engineers don't have the time to worry about that. And so then we have to loop in like a full stack engineer from like a different team, and it's just like it's such a mess. And so we continued to just make it work, but it was pretty tough. And then I think as our data set started to grow, it started to become more important to be able to visualize the data too and understand like, hey, how are we doing in different scenarios? What's our performance like? What are the high loss examples? What do they look like? And so we started as well at that point that was probably about like three years in, we started to try to build that in-house as well. And just see like how long we could kind of push this in-house development. And there was a very long development process, and like we finally started to get something together, but we never really got to a point where it was being used like throughout the company. And so that was a little frustrating. And so I think that was at the point where like, okay, we've invested a lot of time trying to do this. It's still not like providing us business outcomes. And so, it's just kind of a tipping point. It's like, okay, we have to just go with somebody who's an expert who can actually work on this and build like a really good tool full-time, an entire team that's like dedicating their, day in, day out to this. And so that we kind of hit that tipping point.
It's an interesting point around sort of internal usage, right? I think ultimately that's the test. If you're building some tool internally and your internal annotators or your data team or your machine learning team sort of don't really want to use it anymore, then that's, you got to be user focused, whether those users are internal or external.
Totally, yeah.
And then I suppose having made that decision, there are a few different aspects motivating it. You talked about there was the cost and the focus. There was just the sort of the quality of the tooling. There was the point around you're needing to sort of add new features, right? The visualization being a good example, but potentially in the future. Where do you feel having made that shift? Like, do you think you made it at the right time? Was it a bit too early? Was it a bit too late? Or what are the signals you think other people should be looking out for that tell them now's the time to be having this conversation?
Yeah. I mean, it's been so much more helpful since we've started using Encord. And I think, I would probably say we made a decision a bit later than a lot of the team would have liked to. A lot of it was just like funding constraints and budget constraints actually for us internally. But I mean, in like a dream world, I would have liked to have started, at least a year before we did. I think it's probably a combination of, you definitely want to get to, I'd say, like product market fit probably, because otherwise you don't even know what you're trying to build. So, it's just not really worth trying to optimize something that hasn't even shown promise yet. So you definitely want to get there. But I think it's probably even a bit step beyond that, because you also want to have so much data that you're kind of overwhelmed with it. And you're not even sure like how to improve your models and like what direction do you need to improve them. Like that starts to become a problem at a certain point. And for some people it might happen sooner because we're consumers, so maybe it happened for us later. But so I think like when you start to get to that point where it's like, man, this is just so much data. I don't even know like how our model is performing in different scenarios. I want to understand like what do I need to work on. So I think that's like probably a time. And then the other one would probably be like depending on how you're doing your annotations, I think like as that complexity starts to increase too, and you're making lots of changes and you're adding lots of new like features, lots of new things that you need to label, that'd probably be like maybe another indicator, which I think kind of happened for us too. A combination of all those.
Makes complete sense. We've got another poll as well we can launch now to ask, for those in the audience, what's the biggest factor that's kind of driving infrastructure decisions people have now, whether it's on the build side or on the buy side, and that might depend on what stage you're at too. Cool. And then thinking about, I suppose, SwingVision in particular, let's talk a bit about the data infrastructure that you have now. We'll bring in someone from the team in just a minute, but at a high level, what do you see as the benefits you have from the more modern infrastructure that you're now working with?
Yeah, I mean, I think just being able to visualize your data is like so key. Back when I was working at full-time in a different company, like in autonomous driving, like that was just so important to just get a sense of like, what does your data look like? Even what is the distribution? Where do we need to be focusing more? Where do we need to be getting more data, or just like labeling more? Or where do we need to go back and like relabel because something was labeled incorrectly and we like changed how we do things? And all those little things can kind of like just slip through the cracks. And so I think just being able to visualize, being able to like sort by different things, like different criteria, different metrics, that's just like massive, I think. So for us in particular, that was a big part of it. And this was such a difficult thing for us to build in-house, I would say. And not only just build it and be able to see it like this, but also like make it a smooth experience, like a good UX and all of that. So I think it's just making that part painless, I think, is probably like the biggest benefit that we saw right away.
Yeah, I've the ML teams I've worked with in the past, I think it's always a bit underrated just looking at the data at scale. And
Totally.
there are so many bugs, so many mistakes, so many models that don't converge when you train them, that when you inspect the data, you go, aha, all of these images are blank, or aha, all the images are upside down, or whatever it might be. So just getting to look at things in scale, there's no substitute for the human eyes and human brain sometimes.
Yeah, definitely. It's like, I feel like that part of it's kind of like an art too, not just a science, but that's I think why it's overlooked all the time. But yeah, it's very, very critical.
Absolutely. Nice. Well, so now we're going to bring in Angela, who's a machine learning engineer from SwingVision's AI team. Here she is. Welcome, Angela.
Hi everyone.
So yeah, Angela's here to tell us a bit more detail on the technical side about the SwingVision the setup. So yeah, Angela, tell us about your data ops pipeline and yeah, some of the challenges you had to deal with. I know there are some around some difficult edge cases that had to be picked up.
Yeah, absolutely. So yeah, I would like to focus on the retrain and fine tune portion of this diagram. Basically, as has been emphasized, a really early benefit was just being able to get eyes on our entire data set. And that surfaced a lot of different edge cases. That's really helped us prune our data set, upsample certain edge cases, and retrain our models with that information. Next slide, please. So for a more concrete example of what I mean by needing to prune the data set, we have an example here of what is a recording angle that we no longer support and no longer recommend. So as you can see, there's the recording angles kind of lower to the ground and from the corner of the court. Whereas on the right side is an example of our modern setup and recommendation. It's centered on the court and it's much higher. And as you can see, the far side of the court is much less compressed within the frame compared to the deprecated recording angle. And so this helps us a lot with tracking bounces on the far side of the court much better. And so something that we noticed very early on after migrating to the platform is the data set that we had more deprecated camera angles than we expected. So previously, because of certain memory constraints, we only ever had eyes on the videos that we were actively in process of labeling. And after we labeled them, we would offload them. So we had some kind of vague intuitions of what made up our data set, but it wasn't until we really got eyes on it that we realized that there was actually a larger percentage than we expected with this deprecated angle. So that was a very early action item for us, is to try to prune these angles out. Yeah. Next slide, please. Yeah, so another edge case that we wanted to look at is clay courts, or just court textures in general. But for those of us that might be familiar with automated line calling for tennis, clay courts are kind of are known to be problematic, even at the professional level. And so we wanted to find clay courts within our data set, but unfortunately we weren't in the practice of labeling court surfaces until fairly recently. So instead of trying to do a bunch of manual labeling or try to scrape some data and train a model from scratch to predict these surfaces, what we wanted to try is to upload some model embeddings and see if there are natural clusters that kind of correspond with different court textures. So what we're looking at here is we uploaded embeddings from an early layer of an internal model, and then the platform does some dimensionality reduction on its end, and we're looking at the projection of the embeddings onto a 2D plot. So there aren't super clear clusters, which might be expected because courts are more similar to each other than different. But we do see that there are some cluster type shapes. And if we look at this bottom left cluster that's highlighted in the plot, next slide, please. We can see that it seems to represent our red clay courts. And as an aside, maybe this is a good visualization for understanding why clay courts can be problematic. The texture of the court is very different from the hard courts that are much, much more popular in the US. The clay can kind of dust over and occlude the lines that delineate the boundaries of the court. And there's no color contrast between what is considered within the court and outside of the court. And so being able to surface these examples without, again, kind of training a model to do it or doing a bunch of manual labeling was very helpful for being able to start working on these edge cases. Next slide, please. Yeah, so this is an example of an edge case that we became aware of more recently and are actively working on mitigating. So this example, the ball hits the net tape and then bounces up and out of the court. And so why the model might be confused is it sees the inflection point of the ball's trajectory when it bounces off of the tape. And so it might interpret the ball as, instead of bouncing off of the tape, bouncing in the court as usual, in the part of the court that's slightly occluded by the tape. In which case it would predict that the ball lands within the court, but of course we can see that it lands out. And so this is an edge case that was, once again, very helpful to be able to just see directly. And with the video, we can much better understand what might be going wrong with the model in these cases. So yeah, I guess that kind of brings us from more older edge cases in our data set to newer edge cases that we're kind of actively working on currently.
Yeah. Nice. And once you've used that tooling to find those edge cases, what's the next step for you? What do you do with them once you've identified them in the data?
Yeah, so I guess the start of this is identifying them. And of course, this is a very specific niche edge case. So it does kind of need manual validation because there are many trajectories that might hit the net but not have this bounce. It might just clip the net but kind of continue its original trajectory. So yeah, I guess the first part of this was just to actually find these examples such that we can upsample them in future trainings. But the other part of this is because it's such a niche example, we might just have to gather more data. And so something that the team does in situations where we have a very specific scenario we'd like to replicate is we will actually go out and record our own data. There are some very talented tennis players in office. I'm not one of them, but there are some very talented players that can have a lot of directional control and can kind of target the net. But failing that, we also have a ball machine that we have set up to kind of, if we need really high replication. So yeah, that's something that actually the team does fairly often, is kind of go out and collect our own data.
Nice, super interesting. Synthetic data generation, but out there in the real world. I presumably the ball machine, I guess, useful for those kind of individual shots you're trying to upsample, but the players for perhaps if there's a rally or something like that, some data point that involves some back and forth, then that's where they get involved. Is that right?
Yeah, absolutely. So if it depends on if we just need one very specific type of trajectory or if we need something that happens in a rally. Yeah, like I said, some of the players in our office can get really close to the lines, remarkably so. So really great, having people on the team with that ability.
Nice. We've got one more poll to put out as well. So this is asking everyone in the audience, what are the biggest challenges that they're seeing around handling those tough edge cases? Is it finding them? Is it understanding what you do with them afterwards? Is it making sure that the ground truth labels are correct as well? Challenges that lots of ML teams face. Maybe just to wrap up this segment as well. Swapna, would you have any advice for a head of ML or a CTO or a head of data who's starting to think about building out this kind of infrastructure to capture difficult edge cases like this?
Yeah, I mean, I think if you're at the point where, like I mentioned, you're have so much data that you're not able to really get through it, and you're not even sure if you don't even know like what your edge cases are. I guess let's put it that way. That's probably a good place to start considering a service like Encord, and it's just gonna enable you to just move like a lot faster. And there's lots of interesting ways you can go about that. I think some of the ones that Angela shared are really great, and even just looking at like sorting your examples by like loss for any particular like output that you have from your model. Like there's just so many great ways you can do that. And like we've talked about, sometimes just nothing beats looking at the data. And I think, a tool like Encord is just going to make that a lot easier for you to understand and just get sort of a high level, overview, like, hey, how are we performing? And we'll probably just give you more confidence going forward too, in terms of, okay, here's what we need to work on. And, there's many ways you can solve those problems, but at least like what direction you need to go.
Yeah, I guess it's a nice use case here where the data is very naturally interpretable, right? If you played a bit of tennis, you can watch videos, you can understand what's going on.
Yeah.
But so we'll talk a little bit now about the future for SwingVision, and we'll keep you online, Angela, because I think there might be a question going into more detail on some of this coming for you afterwards. But from your perspective, so what's next for SwingVision? What's the plan for scale or your priorities as you continue to grow?
Yeah, I mean, definitely in the short term, line calling continues to be a very big priority for us. We're actually going through a sort of independent certification process where they will validate, an organization will validate our accuracy and give us like a stamp of approval, so it could be used at tournaments all throughout the world. And so, being able to improve various edge cases with our line calling, any mistakes that our system's making, that's going to be very important. So that's kind of what we have in the near term. And then going into like next year, there's additional sports that we want to expand into. So, certainly racket sports initially will be the focus. And so paddle is the fastest growing sport outside the US now, which I'm sure you're seeing in the UK. That's going to be our third sport. So we're really excited about that one. And that has its own challenges. We're going to have to label things a little differently because you can actually hit off of a wall. And so the ball is going to be making contact with the wall a lot. And so that's like a completely different event that our model has never seen before. So I think it's going to be an interesting challenge for us to support that sport. And then also we want to go to additional platforms. So, I mean, we've been exclusive to iOS for the longest time. A lot of that's because of our models running on device and the, inference and hardware requirements that we've had. But we're seeing really great performance in kind of recent Android devices as well, kind of on par with Apple Silicon. So that's an exciting opportunity for us. But obviously there's a wide variety of devices there. And so, that's going to have its own challenges from the model side in terms of, how can we optimize our models for every type of hardware that's out there. And I'm sure that Encord will help us, address that in some way too. So really excited for that challenge too. But I think those are some of the big ones that we have coming up and all kind of ML related to some extent.
Nice. Yeah, I think that the challenge with paddle coming off the wall could be challenging. remember, we're multimodal, so if you want to include the audio of the video in there, you know, hearing it bang off the wall, perhaps that's
yes, that's a good point. So audio is something we've actually already started experimenting with internally. I think that's a really cool opportunity for paddle for sure. Even for pickleball, it's interesting. Like when the ball makes contact with the paddle, if you're behind the person, you can't actually see exactly when, because you can't see through the paddle, unlike tennis. And so, you know, audio is potentially helpful there to understand exactly when that contact happened. And so there's just all kinds of situations there where I think audio is going to be really helpful. So that's definitely something we'll be looking into as well.
Yeah, I guess those double games where you have like one person occluding the other as well.
Yep. Yeah.
Nice. Super. Well, we'll sum up now and then come to talk on questions. So I think we had one question first from the audience I've got, which is one for you, Angela. So the question, this is from Daniel, asks, Angela, how specifically did you use the tooling to find these edge cases? So perhaps we go into a bit more detail. I can go back on the slides as well to talk about how we're finding perhaps these edge cases, but also these ones too.
Yeah, so this one is not super glamorous. I just did some filtering in the SDK that Encord provides, looking for instances where we do label when the ball interacts with the net. So just instances where the ball hits the net and then bounces out. And, you know, because we label the types of shots, we know exactly like what is counted as within the court versus outside. So this case was just an example of just looking through all of these instances where the ball hits the net tape, which is a relatively rare occurrence in our data set. But moving forward, once we get the chance to, I guess we're currently in the process of retraining our models based off of some of these edge cases that we've talked about. And so once those retrains are done and we have the opportunity to upload those predictions and losses to the platform, then we can also look at you know, net interactions with very high loss. So I think that would surface more than just this specific example, but yeah, in general, we're looking for examples where the model struggles with net interactions.
Yeah, great. And I suppose the case you used here for the clay courts, where we're looking at the embedding space, potentially also once some of those net interactions have been labeled, then plausibly they're near neighbors inside the embedding space as well. So potentially visualizations like this, or the sort of nearest neighbor inside the embedding space similarity search could help pull some of those through as well. Super. Let's see, with any other questions we have from the audience? Yeah, thank you, Daniel. So if not, we can wrap things up. We're almost at time. Oh, no, there's one that's just come through from Drew. So yes, so he's asking what does Encord help with aside from having the overwhelming data set? So I don't know, potentially could talk about the annotation side of things and the ability to create high quality labels. Also a great moment for the pop-up there. So you can always visit our website as well and see the product interactively. So I don't know, maybe Swinton, you could talk to us quickly about what your annotation process looks like.
Yeah, I mean, or Angela, if you wanted to answer that one, you feel free to take it too, because you definitely have a deeper understanding of it probably at this point. So.
Yeah, yeah. So on the annotation side, something that we had trouble with beforehand is, I guess, like workload sharing. So we kind of had to do a lot of kind of hacky stuff to make sure that people weren't working on the same video at the same time, that there weren't any kind of collisions between labelers. And then also we kind of had to kind of just let them know what they should prioritize. Whereas now there are queues within the platform, and so they kind of log on, they look at the most recent item in the queue. If they initiate that task, then it's no longer available to any of the other labelers. And then, yeah, like I said, kind of prioritizing tasks. We've also implemented some Encord agents in the background, which is just instances where we can inject our own code into the workflow. So that has also been really helpful for basically kind of moving tasks down the pipeline to where they need to be, setting priorities, et cetera. So it's just been a much more straightforward process for our labelers.
Yeah, I think that speaks to a point we made earlier as well about sort of moving to a larger scale of annotation. I think often early on, when there's just a handful of annotators, or maybe even one person annotating, then you can get away with an Excel spreadsheet that says this person annotates this video, this person annotates that one. Once you get into a larger scale, then perhaps if you want to have some more complex workflow where there are, perhaps one person is manually annotating, then an agent is reviewing it, and then perhaps a second person is manually reviewing in certain cases as well, then it kind of becomes a little bit unscalable to do that manually, and some tooling that helps you allocate people to tasks, whether it's manually annotating, whether it's reviewing something that's done automatically, starts to get challenging. Yeah. Nice. Cool. So just to wrap things up. So yeah, if there are any questions anyone has about Encord, about our products, how it works, then got an interactive tour available at this link here, so you can go and see some of the points that Swipnil and Angela made there in terms of how they're using the product, see how they might apply to use cases that you have as well. So and to answer your question, Bob, sometimes that's manual annotation, sometimes it's data exploration, and sometimes it's on the active learning side. Once a model has already been applied to some data, uploading those predictions to the platform, and then visualizing model predictions, visualizing sort of model quality as well, and these various metrics. So yeah, if you're interested, please go there and have a look. And if you're a tennis fan or an aspiring player, then definitely give SwingVision a look if you haven't already. And thanks again to Swipnil and for Angela for their time and for being part of the webinar today. Really appreciate it, guys.
Thanks, James. Thanks, everyone.
Yeah, thank you, everyone.